Welcome back. In the last session, we discussed about taking a ABAP to SAP HANA, topics such as how to access SAP HANA database by using OpenSQL and a secondary DB connection, and some of the performance tool, static performance tools such as SCI and ABAP Test Cockpit, and runtime analysis tools such as ABAP Trace and ABAP Profiling Perspective, and some of the most important databases tools such as SQLM, SQL Monitor, SWLT, and ST05 traces, and some of the golden rules for ABAP and SAP HANA. So in this unit, we will be discussing about core to data with SAP HANA as a secondary database. So here in this unit, we will be discussing how to optimize ABAP applications using SAP HANA as a secondary database, and ADBC, ABAP database connectivity, and native SQL syntax. How Because native SQL syntax will be used by SAP HANA, so native SQL syntax. So finding and analyzing views in SAP HANA. So how views like HANA specific views like attribute views, analytical views, calculation views in HANA Studio, how to find them and how to analyze them, and different types of SAP HANA views, what are the features of them, and consuming SAP HANA views in secondary SAP HANA database, secondary database like SAP HANA database, working with database procedures, so HANA views and HANA database procedures stored on SAP HANA, and consuming SAP HANA database procedures, how you can consume it is in a BAP and in a secondary SAP HANA database, how you can consume them, we can see in this unit. So more specifically into SAP HANA, HANA views, native SQL, HANA stored procedures. So these things we will be discussing in this unit. So paradigm changes. This is the most important and famous slide here. So traditional approach will be code to data paradigm, data to code paradigm. That means that in a traditional approach, we will query in our we write our code like select and select queries. For example, select queries in our application layer, and when you write your code in application layer, so it will fetch the data from DB layer to application layer. It pushes massive data from DB layer to application layer. It and It sends the results from DB layer to fetch the data from DB layer to application layer based on the request. So here you means that you are writing your code in the application layer and fetching the data from DB layer. This is the most massive data transferred from DB layer to application layer. That means that you are having more effect in application layer rather than DB layer. So it will affect performance and it reduces the performance of your application. That means that it fetches the data, and when you and displays in the application layer, it takes so much time consumption, and speed also becomes less in the data to code paradigm. So coming to code to data paradigm, you can have your calculations or code inside your DB layer and push back the results from DB layer to application layer upon the request. So it gives more performance. ABAP code really benefit from SAP HANA using code to data paradigm. Many data intensive operations on the application server we are executing nowadays. So high performance applications actually delegate your operations to SAP HANA layer uh, rather than the application server. So we'll use OpenSQL, but we'll have more effect on database layer. So we'll only send the results from DB layer to application layer and write calculations in the DB layer. Code to data paradigm is more effective and it's it results very fast since you are doing in-memory calculations you are doing in DB layer. So code to data paradigm. So OpenSQL. So what is an OpenSQL? So what is an SQL and what is an OpenSQL first? So in general, OpenSQL has a uniform syntax and semantics for all database systems, whether it is HANA, whether it is MySQL, or whether it is any other database. So it has uniform syntax and semantics supported by SAP for all database systems. So OpenSQL only works with database tables that are defined in a ABAP dictionary. That means that in SE11, when you define tables or any artifacts for ABAP, these things only can be accessed using OpenSQL. Using secondary DB connection is also possible, which we have seen in the previous session that how to access, if you have SAP HANA as a secondary database, how you will access the tables of the secondary database in your OpenSQL using select query and a connection syntax. So ABAP programs that only uses OpenSQL will work in ABAP system regardless of database. So the programs that use OpenSQL will work in only in the ABAP system regardless of the database. OpenSQL is embedded into an ABAP language. Consider, for example, variable binding, software logistics, automatic client handling. So these things happens through OpenSQL. Use OpenSQL as much as possible. So rather than native SQL, use OpenSQL because everything will, all the databases can understand OpenSQL. To some extent, actually, OpenSQL allows executing logic in SAP HANA data layer and to improve performance and provides the performance recommendations to be kept in mind. So OpenSQL also provides the advantages like reflects a subset of standard SQL. It's a subset. OpenSQL can be considered as a subset of SQL. So we can say SQL is the main node if we consider. So OpenSQL is a subset and is a one node, and native SQL is another node. So OpenSQL should be used as much as possible in a desired way. Coming to SQL, so SQL, native SQL is largely standardized for NEC SQL, but each vendor adds own features actually. In ABAP release lower than ABAP 7.4, only data manipulation language is reflected in ABAP as OpenSQL with unified syntax and semantics. So less than 7.4, it supports only data manipulation language like selects, inserts, update, and deletes. So it's reflected in ABAP in OpenSQL less than 7.4, standard by reading and changing data in database tables. So the data definition language is reflected considerably away in the ABAP dictionary. Only the changes with the 7.4, where the core data services languages started means greater than 7.4 CDS views come into picture. New ABAP dictionary, so DDL data definition. So this is possible only from 7.4. So DCL is data control language like authorizations is not yet reflected in the web systems at all. Due to how web system interacts now, even if we create a data control language using uh, uh, ADT, that won't be reflected in the web system as of now. So data definition language, DML, data, insert, update, delete operations, reading and changing the database tables is supported less than 7.4 in ABAP. Data definition language is supported above 7.4 and above, which we have seen core data services are supported above 7.4. Data control language like authorizations, these are not yet supported in ABAP, so it can be created from um, ADT. Suppose DCL, how you create a DCL was I'll go to ABAP perspective. So if you go to any of the package, you can right click and click on new. Sorry, if you go to dictionary, click on new, you can have data definition. You can go to other ABAP dictionary objects. You can have data definition, data control language as well. So it maybe it is supported. I will try to data control. So it is supported above 7.5, 7.5 ABAP 7.5. Consistency checks not yet reflected in ABAP. So ABAP database integration. An ABAP system interacts with its database using two layers actually. When you have a ABAP system, how the ABAP system, if you go back to the slides, the application layer is nothing but ABAP. Interacts with the DB layer, whether it is HANA, another. It interacts with the database with two layers actually. So it interacts with the with the database interface. Actually, in between ABAP and application layer and DB layer, you have a database interface layer, DBI. We call it as a DBI interface, and it provides a database independent interface and adds services like automatic client handling or ABAP table buffer. So database interface acts as a table buffer, and client dependent will be handling by DBI. So DBI is just above a layer of above database layer, so which acts as used for buffering and client handling. So database specific layer connects. There was another layer called DBSL, database specific library, connects the respective database and translates OpenSQL statements into native SQL when using primary database connection. So suppose there are two layers actually. As I said, first one was DBI, database interface, just about DB layer. So that used for client handling and buffering. So as soon as when you trigger a select query from your application layer, so if a table was buffered, so it will fetch that from the DB layer to DBI layer. So when you do first time, it will fetch from the DB layer. Second time, if you use the same table again with some select values, it will fetch from the buffer. So there will be another layer above DB layer called database DBSL. So what it does was when you write a select query, you write in a OpenSQL. So it will convert it. DBSL layer converts from your OpenSQL statement to native SQL, because native SQL will be understandable by the DB. So DB doesn't understand OpenSQL, so it understands only native SQL. That's why. So DBSL layer is the layer which converts your OpenSQL statement to native SQL. So we have two layers. Um, so one layer will be used for client handling and buffering. So other layer will be used for translating OpenSQL to NetSQL. It's connects and is also used for connecting to database DBSL. So different remote database possible with multiple DB clients. So remote database, like you will have primary database connection, secondary database connection. So you can have multiple DBs connected to application layer. So that can be checked using the DBA cockpit, which I have shown you in the previous sessions. If you go to DBA cockpit, you can see what are the um, um, databases connected to the external system. So in DBA cockpit, you will be able to see all the multiple connections which is connected to your ABAP system. So system configuration you can check here. So database connections you can check here, like MaxDB connections. What are the SAP HANA database connections? You can check here. Microsoft SQL Server connections you can check here. So you can have system configuration as well. You can check from the system configurations as well. So which system is this? So disabled system configurations also can be checked. So different remote database possible with multiple DB clients, ABAP database users, um, and schemas. So each every table which you create, so which you create in your um, database will be attached to one schema. Suppose if you create any table here in your ECC system, suppose EC7 system, suppose. So here schema name will be SAP EC7. So it will be SAP will be appended before your system name SysID. So there every table which you create will be attached to one schema. So ABAP database users and schemas. So which suppose if you go to this database connections, so here, if you go to SAP HANA system, so this is my database system. If you see the user database user is SLT underscore EC7, connection name was this, that all the tables associated to SLT is EC7. If you create any table, it will be attached to this schema SLT underscore E7. I can show here from here in my SAP HANA studio from my report desktop connection. So this is my HANA system. So HDB connection. So HDB connection. So in this HDB connection, I'm opening SLT underscore 17 is the database user. So these are the tables associated with database user. If I open any of the table here, like mark new. So if I open here, if you see SLT underscore mark, so that is my schema name will be appended to mark. So when I double click on this, so sorry, when I see the properties of these properties, I can see check the properties as well. So check properties. So I can see open content or open definition. So control, if I see the history or if I see the table properties, I will HDB select. So I'll be selecting open data connection, the preview, open content. So job log, property value, generally you can see all the which schema it is belong to, which package it belong, which table. When you create any table, it should be belong to one schema. So if you see this mark new is belong to schema SLT underscore EC7. So schemas, if you see the schemas here, so everything should be attached to one schema. Yeah. So I'll try to open any of the table, or suppose if I open DC02, so HDB system, if you see system details, see you can see here table name and schema name. So every table is attached, will be attached to all the artifacts which you create in your database will be attached to one schema. So, so translation of OpenSQL to into SQL, which I have shown already in SQL trace. So when you go for ST05, ST05 is a transition where you will be having all the trace results. So if you have display the trace, so any of the trace, if you display any of the trace, so if it open any of the trace, suppose select query, it will convert your OpenSQL statement into native SQL statement. All the variables, everything will be displayed here. So native SQL converted, you can see it from the SQL trace. Limitations of OpenSQL less than 7.4. So there are many limitations in OpenSQL from less than 7. The scope was limited because many database systems did not support the full SQL standard yet. I already told you it supported only DML, like data manipulation language. Classic OpenSQL, as available in ABAP release 7.5, does not support expressions in column list. So if in column list, if you wanted to have any expressions, unions, all type of joins, subqueries, in the select and from class are not supported. In addition, because of OpenSQL is to provide a common syntax and semantics across all supported database system, it cannot support database specific SQL, for example, function specific to SQL HANA. So since these things are not supported, as I said, you need to use native SQL if you have to use any of these features to achieve desired performance for your applications in a ABAP release below 7.4 and SP2. So subqueries in select are from class, unions, case expressions, additional join types, HANA built-in functions. Accessing HANA views are not supported less than 7.4. So you have a HANA views if you wanted to access in above, those cannot be accessed, and stored procedures if you wanted to access, those are not supported less than 7.4. These are some of the limitations in OpenSQL. So above database connectivity. So ADBC is uh, ABAP database. It's a connectivity to our HANA database. So through this, you will be accessing all the HANA specific HANA tables, HANA specific functionalities can be accessed using ADBC ABAP database connectivity. So there are ABAP APIs for native SQL calls. If you have a native SQL in your and in your HANA is mainly you access your tables using native SQL. So access in ABAP, you wanted to access your native SQL in ABAP, you can do it using ADBC connectivity. So there will be APIs for that, object based. So this is object based. You will have certain classes to access create a connection to your HANA database and access your execute your select query. Your native SQL select can be accessed using ADBC classes. Supports error handling and where user list. So it supports error handling and where user list. So ADBC is a API for native SQL calls in ABAP. So if you have a native SQL select, so if you wanted to access using ABAP, then you will use ADBC. It allows native SQL calls are used and supports. It also supports handling exceptions and where user list. It is flexible and it is object oriented. Um, Three main classes which is used for ADBC were SQL connection. SQL connection is used to establish a connection to your HANA system. SQL statement is used for calling your select query, like a native SQL statement. So can be defined using a CLSQL statement. So CLSQL result set is used for executing your query. So to open a connection, you will use CLSQL connection. To write a native SQL query, means to write a select query, suppose you will use CLSQL statement. To execute a query, you will use CLSQL result and set. So Uh, th- uh, the logic sequence to issue a native SQL query using ADBC, I will be showing you in the system. So how to execute, how to call, establish a connection, and how to establish a query, how to write a query, and how to get the results in, and how do we close the connection as well. So there's certain steps which you need to follow to connect to your native SQL in ABAP, to write your to access your native SQL in ABAP. So these ADBC will be used, these classes and ADBCs will be used when you define a HANA view, or if in your HANA database and you wanted to access in OpenSQL. If you have a stored procedure in HANA and you wanted to access using ABAP, then you will use ADBC. So uh, the first step for accessing these will be showing you. I have an exercise here. So using a native SQL using ADBC. So I'll go to system. So I will go to report. I will go to SAT. So we'll wait for the system to respond. I have exercise. So what exercise for me will be native SQL. So native SQL, I have it in my package. So open. I'll open the system again. So I lost my connectivity. So I'll open the system again. So I'll connect to my ECC system. So I will open my package. So I have a code snippet already done to execute an ADBC using to access native SQL. So I will be using that. So I will be using Open SQL. So I'll be using ADBC. So this is my report program to access native SQL. So I'll just maximize it to full screen. So if you see here, this is a report to access native SQL. So first step would be to establish a database connection. It is necessary because only we will be using a secondary database connection to access native SQL call. So you will use create object. You will create a CLSQL statement. So here for this statement, you will be for this. If I go to the CLSQL statement, so there will be constructor for this CLSQL statement. So if we go to constructor, the constructor constructor is we have C. It has two parameters. It's exporting parameters. So the parameters is type reference to, and these are constructor has two optional exporting parameters. So constructor needs two. It's taking connection reference and the table name to. So what I'm doing was for this CLSQL statement. So I'm creating an object first. So and I'm passing a connection. So you already know in from the DBA cockpit the connection HANA system, the secondary DB connection was this is the secondary DB connection. So if I go to DBA cockpit again and show you, so I'll just DBA cockpit. So in DBA cockpit, if I go to database connections, SAP HANA databases. So we executed this in the previous sessions. So if I go to this is my HANA system, which is executing perfectly. So you see this is executing perfectly. So I need to connect this system in ABAP. So this connection I will be establishing using ADBC. So classes was CLSQL statement. This is if you see CLSQL statement is used for uh, executing your query. So here I'm creating an object for CLSQL statement. For this statement, I need to pass importing connection reference CLSQL connection. I am establishing connection here. So get connection. So in this get connection, I'm passing my connection, my HANA system and passing it. So here I will be passing to my statement. I am importing the database connection. to HANA system. So whatever HANA system which is successfully executing, that HANA system can be sent. And then I'm connecting a select star from mark into LVSQL. That means that I'm selecting a native SQL syntax. I can do it two things as well, like mandate from, I can do these things into LVSQL. So here in the LVSQL, so I'm just editing it. So I'm just selecting my material number from my schema name and then mark table. So if you see, so in this SLT underscore EC7 is my um, uh, schema name. This is mark was my table. So in this connection, I'm selecting mark. So if you see here, LR result, CLSQL result set is used for executing the query and getting the result. This is used for storing the result. So and setting the parameters to the table. And finally, I have to close my connection. So here, all the declarations will declare a statement and then result set and some exceptions. So we do a create statement here. So the create statement is importing the connection here, the data HANA connection, and you will execute the query um, passing SQL query as a string. So this is SQL query as a string, and you are passing it into uh, executing the query and storing the result here. So storing the result here. So finally, you have to close the result and handle the exception. You can do some exception handling here as well, and retrieve the result as well. So you can assign the internal table, the result which you have got. You can assign them to an internal table. So here, if you see, if I am debugging it, so I'm clicking on F8. If you see here, I'm establishing a connection here. So before LR SQL, if you give LR underscore SQL, it is, I'm just clicking on F7. So LR SQL was initial now. So I'm clicking on F5. LR SQL is initial now. So I'm clicking on F5. So F7. So if you see here, LR SQL was executed with CLSQL statement. I'm going to desktop 3 and I'm showing you. So the CLSQL statement is executed now. If you see in CLSQL statement, so it has a connection ref. If I go to connection ref, I can see it is connected to this system. The database is HDB is connected. Yes, it's connected. So default was CT and code. So all the other things you can see here. So if I go back and see, I have unmove parameter, connection reference parameters. ITAB reference is not yet initialized. So table name for trace is not also not yet. I'm not passing that. I'm passing only connection reference. So connection reference was successful. So I'm creating a native SQL statement in LVSQL. So this is select start from Mac is my native SQL. So I'm just manipulating this LVSQL. So I can do only mandate as well. Instead of star, I'm selecting only mandate. So I'm executing the query here. So well, the result, if you see, I'm executing the query result set. So if you see the result set, I have parameters. So if I go to parameters tab, so data ref, everything was blank. So if I go to LRSQL now, I'm closing it. So its table was initial. So parameters, SQL parameters, parameter table. If we go data ref, I'm just getting this result set parameter table. Now if I see this set parameter table, LR result. Now if you see ITAB reference was assigned, ITAB line reference was assigned. That means that I got, if you go to type mark, I got all the fields here. Desktop 3. And if I go to this LR field, this is the table LT LR. If you see this LT table, so all this LT table was reflected in error results. I have to close the result set as well and then click on F8. So this is how you do ADBC and connection to it. So to access from a native SQL using ADBC, will access this. So if I suppose if I remove this R and if I execute this, it won't establish a connection for me. So if I debug now, so if I click on F5 now, F6 now, see it went to catch. That means that it went to dump. It's showing that it is not connection was not successful. So you need to give exact name here and you need to query properly. So this is how you use your native SQL using ADBC. So what are the things to keep in mind when using the native ADBC? There will be no syntax check at compile time, no hashed or sorted tables as the target. So when you use ADBC, you should use standard tables. So when you declare LT table of mark, when you are selecting as an, you should use a standard table. There is no hashed table or sorted table supported. So that you have to keep this in mind. No syntax at the compile time. A developer is responsible for client handling and accessing correct database schema, releasing DB resources, proper locking and commit handling. So these things are not automatically handled. So uh, syntax was not checked at runtime at compile time. Uh, table target table should be standard. It should not be hashed as sorted table. Developer is responsible for client handling like mandate. So since you are accessing your native SQL to open SQL write statement. So when you are doing that, so here you should, when you are writing your select query, you should have a client handling and all the schemas, all the database connectivity connection system should be proper. So otherwise it won't get you the result. Releasing DBO resources like connection closures, closing the connection, everything should be taken care here. So proper locking and committing changes should be kept in mind. So what is native SQL? So native SQL in a BAP. So what is native SQL in a BAP? So native SQL in a BAP is nothing but it's loosely integrated into a BAP. Syntax of native SQL is not checked. So statements are directly sent into DB system. So if you write a native SQL, it won't convert. So if you when you are writing OpenSQL, it will be converted into native SQL and then sent into DB layer. But when you do a native SQL directly in a BAP, that means that you're directly sending to DB. There is no conversion. So syntax of native SQL is not checked. No automatic client handling and buffering. You should explicitly specify uh, client handling. So no, all tables in all schemas can be accessed if you use native SQL. So all tables, all schemas with a schema name, you can access everything. So using native SQL in a BAP. So common things between native SQL and OpenSQL. So common thing was keywords are case sensitive. So keywords are case sensitive in both. So when you use lowercase, it will take into lowercase. When you do use uppercase, this is a case sensitive. You should use keywords properly. Table and column name seems case sensitive, but be careful. HANA converts them to uppercase unless quoted. So column names. So when you are writing a select query, select material number. The mandate column name should be a uppercase. So converts them to uppercase unless quoted. Okay, you should or default the column name should be uppercase. Import syntax differences was when you write a OpenSQL, where you won't use a comma for your column list, but in native SQL you should use a column list. Table and column name qualifiers are separated using dot. So when you are accessing use a schema name, then you use schema dot. No for all entries on no corresponding fields in your native SQL. These are known only to ABAP and OpenSQL. So in native SQL, there is no for all entries, no corresponding fields. So native SQL and OpenSQL syntax. So syntax will be, if you see the syntax here, comma separated. So columns are comma separated, and if you see here, columns are comma separated, and if you see when you accessing any table, you should specify the schema name before the table name. Then only it knows the table belongs to the schema and it will access the same, and every column should be comma separated. So if you see here in this mark was the schema, so SLT EC7 and table name mark. So that is why when I am accessing this I will be using select char id con id from SLT dot OpenSQL. It will be only with uh, normal, there won't be any column list. So finally, how you test your native SQL in HANA Studio. So how there is no since there is no syntax check for native SQL statement in a app, it can be very tiresome to get the syntax right. A convenient solution would be use the SQL console to view your SAP HANA Studio. Suppose here I used a suppose if I use suppose I went to um, this statement. If you see, I'm using this statement. So I don't know whether this statement executing properly or not. What I will be doing is I will copy this statement in HANA Studio. If you go to HANA Studio, you should select SQL. Open SQL can be selected. So this is SQL console in your database system, SDB system. So I can copy and paste here. So now I can test this whether it is properly executing or not. So if I click on this, that means that it is executing properly. It fetched. If you see, as soon as when I click give here, select fetched 100 rows in 3 milliseconds, 463 microseconds. Processing time, it took this much time. Result limited was 100 rows. So that means that if you wanted to test your SQL, native SQL query which you are using in your OpenSQL, whether it is properly executing or not, how you will test was you can copy this statement, whatever you use. So and we'll go to HANA Studio, converted into SAP HANA Modeler or HANA Studio using virtual monitor, virtual desktop. So you have to go to SQL or OpenSQL and just click on Control V. So select star. I'm using now star now. So when you use star, I'm just giving star from Mac. So I'm just executing it. So if you see here, we got all the data. It took 32 milliseconds, 33 milliseconds to fetch 1000 rows. So that is how. So for every HANA, for every um, uh, view or every HANA view or every HANA stored procedure or any table, you can test using SQL console here. Yeah. So this is how you test your native SQL syntax in HANA Studio. So testing native SQL in HANA Studio we have seen in the exercise. So that's all from Unit 8 here. So Unit 8 mainly deals with coded how you access your native SQL in uh, um, ABAP using ADBC. You will have three object-based classes such as CLSQL connection, CLSQL statement, CLSQL result set. So opening the connection, writing your query using statement, and then executing the query and storing the result set. So what is the difference between OpenSQL and native SQL? What is present OpenSQL below 7.4, above 7.4, and how you call your native SQL in SAP HANA Studio, in SQL console, how you test it, you have seen in this unit. So in the next unit, we discuss about HANA artifacts and HANA Studios. So that's all from this today's session.